Awesome. All right, WEB36. Welcome to scope closures. We're gonna touch a little bit on hoisting and callbacks. Tomorrow we'll do a deeper dive into callbacks, but we're gonna tell you what they mean so that when you hear a reference to them on today's project, you won't be super confused. All right, so all of this stuff, it's likely gonna be asked about in interviews. So probably a good idea to take notes throughout this guided project. So go ahead and open up this blank code pen, give it a fork, and then if you want to reopen it so that you have the most up-to-date notes and the most up-to-date code, that's a good idea as well. So the first thing we're going to talk about is scope. And we've touched a little bit on scope throughout the lesson on variables and functions, because it's impossible to know how those things work without touching on scope. But now I really want to get into the nitty-gritty of scope. So when I say, what is scope, can you explain your current understanding of what scope is in JavaScript? So what is scope? What does that mean to you? And I want to see lots of answers on that thread. I know everyone's done their homework and they've reviewed the training kit before they jumped into the project today with me. So let me know what you learned from the training kit on what scope is. Yeah, how to access variables, perfect. What we do and don't have access to, yeah. Awesome. So scope answers the question of where are my variables and functions available to me? So answers the question of where are my variables and functions available to me? Okay, so we have a couple of different scopes. So we can have global, okay, and we can say something like const cohort equals WEB36. Okay, is this a global variable? Yeah. Why is it global? Because it's accessible to me everywhere in my program. Okay, it's not inside of a function, so it's not restricted by function scope. It's not inside of curly brackets, so it's not restricted by block scope. This const of cohort is available to me anywhere in my program. Okay, I'm gonna say let school equal lambda. This is also a global variable. And I'm gonna say var track equals web. Okay, so I can access these variables of const, let, and var anywhere in my program. There is a difference though between var, let, and const. So I'm gonna open up the browser console. I'm gonna click inspect. I'm gonna go over to console. Can clear this console here. Okay, so if we write these variables in the console, so var track equals web, okay, and then we reference track, we get back web, okay. We can come in here and we can say const school equals lambda. And if we reference school, we get back lambda. But there's a difference between the way const and the way var perform, okay? So technically, if a variable is global, it's accessible on the window scope. So if we do something like window dot track, we get back web. Okay, if we do window dot school, we get back undefined. okay? So only var is attached to the actual window or the global scope, okay? Var, let, and const work a little differently. So while this const and this let is accessible to me anywhere in my program, var is the only one that is truly global. Okay, let's review how these would work inside of a function. Okay, so if I had function sprint 3, and I'm going to pass it in the variable of study, or the parameter of study, and I want a console.log. Let's get some string template literals. We are studying, and I'm going to reference my parameter here of study. Okay, how would I invoke this function with what we are studying? So how do I invoke the function and pass in what we are studying? Yeah, so I want to call the function name. So I'm going to say sprint 3, and I'm going to pass in a string of what we are studying. And we're studying JavaScript fundamentals. Okay, so I'm going to save this, and I'm going to run it. And I get back in the console, we are studying JavaScript fundamentals. Okay, I want to come down here, and I want a console.log study. Before I run this, what will I get back in the console? What will I get back? I'm going to get back undefined. Okay, let's see if that's true. Save, run. Okay, and we get uncaught reference error. Study is not defined. Okay, why can't I access study? Why can't I access study outside of the function? Scope, yes, but why? Is study a variable? No, it's a parameter. So this is what I want to show you here, because I think this is where a lot of the confusion lies when we're new to JavaScript. And I've seen people try to like come in here and say like, let study equal. So what happens here is when we write a function, we have this parameter called study. And when we run the function, whatever we pass in here as an argument, so arguments are actual values that we pass in, parameters are placeholder values. What happens here is that JavaScript fundamentals, the argument we're passing in, is going to replace study anywhere that study appears inside the function. So in this case, it's only in one place, just here. And that's why we get back, we are studying JavaScript fundamentals here. Okay, so wherever study is in the function, when the function is invoked, so when the function actually runs, whatever argument we pass in will replace the parameter. So they're not quite the same as variables. Okay, I just wanted to clear that up. Does that make sense to everyone? Does that make sense? If that was something you were struggling with last week, does that make a little bit more sense now? Yeah, perfect. Okay, awesome. So we have sprint 3, we passed in JavaScript fundamentals. We could pass in something different every time we invoke the function. So I could also pass in a variable here. So I could pass in track, for example. I'm going to comment this out so we don't keep getting that same error. Clear, save, run. Okay, and first I get we are studying JavaScript fundamentals, and then I get we are studying web. How come it could access web? How come web is accessible? Yeah, because it's global. Okay, so if I come down here and I console.log track, I can also access track down here. Okay, it's on the global scope. It's available anywhere in my program. Okay, what happens if I move track inside of here? Clear, save, run. So on the second, when we run it the second time, we get track is not defined. Okay, so how come it's not working on, how come we're getting track is not defined? It's scoped only within the function. So I'm gonna erase that for now. Okay, so here, if I wanted to console.log track, clear, save, run. Now track no longer exists outside of the function. If I come inside of the function and I console.log track, clear, save, run. Hold on. Console.log track is not defined. Bar track equals web. Clear, save, run. We need to invoke the function. Sprint 3. Now we get back web. Okay, so web exists inside the function, but it doesn't exist outside of the function. So there's something going on here. We've just proven something. What we've proven is that functions can reach outside. So functions can reach outside of their scope, but we cannot reach within a function from outside. Okay, so if something is function scoped, it's available to us inside the function, but it's not available to us outside the function. However, functions can reach outside of their scope and access something if it's not available inside of the function. Okay, I want to show you another example of this. So let me comment this out. And I'm going to come down here and I'm going to say function, and let's call it lambda. Okay, and we're going to say const cohort equals WEB36. Okay, and we'll say console.log cohort. And then I want to say const track equals full stack web. Okay, and then I'm going to console.log track. I'm going to come up here and I'm going to say const track equals data science. Okay. And I'm going to come down here and invoke the function. So lambda clear, save, run. Okay, so I get back WEB36 because it's running this console log, and I get back full stack web. Okay, it's running this console log. If I comment this track out and I save, clear, and run again, now I get back WEB36 and I get back data science. Okay, so what's happening here? When we run the function, first the function will look within itself and say, hey, do I have a track defined? And if it does, it will give you that track. If it doesn't, it's going to look outside of the function and say, hey, I don't have track. Global scope, do you have track? And if global scope has track, then this is the track that it's going to get back. Okay, does that make sense? And I have one more example for you in a second. So far, so good? Okay. All right, so let's go back to the differences between var, let, and const, because this is really important here. So I'm gonna comment this out and let's write some notes. So tell me, what do you know? What are the differences? What are the differences between var, let, and const? Okay, so we're gonna write a multi-line comment in JavaScript and tell me what you know. So var, let, and const. I see var is global scoped. Is it global scoped? So var can be redefined. Okay, it can also be reassigned, so it can also be updated. And what kind of scope does var have? Okay, let can be redefined. It can also it cannot be redefined. It can be reassigned. So it can't be, we can't say let school equal lambda and then let school equal something else, but we can say let school equal lambda and then we can go and update it to something else. Const is constant, so it cannot be redefined. It also can't be changed, cannot be updated. But what is the difference with their scoping? So what is var? What kind of scope is var? Yeah, Jen's got it there. var is function scoped. Okay, that means that if var is inside of a function, the function will stop var from escaping. Okay, let is block scoped. Const is block scoped. And let's see the difference between those. So I'll come back to my function of lambda. And I'm going to say var track equals web. And I'm going to console.log track. Okay, and if I come down here and I invoke the function, so lambda, then comment it out up there, yep. Okay, clear, save, run. I get back web. If I try to console.log track outside of the function, I get track is not defined. Okay, so track only exists inside of the function because var is function scoped. Okay, block scoped looks a little differently. So if we have block scope, for example, it is inhibited by just a block of code. It doesn't necessarily have to be a function. So we could say if 1 is equal to 1, const answer equals true. Okay, so if I come down here and I console.log answer, what am I going to get back? What is the result? So I think we can all agree that 1 is in fact equal to 1. So what is our result here? Ah, undefined. Interesting. Save, run. And we get answer is not defined. Okay, I don't want to use a var everywhere. Var is pretty bad practice. If I put a var here, clear, save, run. Now I would get back true, but how would I do this with a let? Does anyone know? Remember that let is also block scoped. How could I rewrite this with let? Because remember that we want to update it if it's true. So how could I maybe rewrite this with let? Yeah, we could define it outside of the if. So we could create it into existence. We could say let answer and just leave it blank. And then we could update it inside of our block of scope. So if 1 equals 1, answer equals true. And if we console log answer here, save, clear, run, we get back true. Okay. Another example of that. So if we had a for loop, because a for loop is a block of code, so it's block scoped, we could say for var equals, for var I equals 0. Okay, I is less than 5, so the loop is going to run 5 times. And here we're going to iterate it. We'll say I plus plus. So this, we're incrementing it by 1 each time. So I'm going to come in here and I'm going to console.log I and see what we get back. Comment that out. Clear, save, run. Okay, and I get 0 to 4 because the first time the loop runs, I equals 0. The second time the loop runs, it increases by 1, so it equals 1. And once it gets to 5, the loop stops running. If I console.log I outside of the loop, I should get 5. Okay, because this is a var, it's accessible outside of the loop. Okay, usually we only want the loop, the var I to be accessible inside of the loop because we're only using it for the purposes of looping through something. So this is why we use a let here. Okay, so clear, save, run. Okay, the loop still runs, but outside of the loop, I is not defined. Okay, so I is not accessible outside of the loop. If we change this to a const, save, run, we get an error after the loop runs once because we can't update a const. So let is what we want to use here. All right, one more example of this. I'm going to make a variable. I'm going to call it dog, and I'm going to assign it the value of atta. And then I'm going to make a function called call dog. And I'm going to console.log dog. inside of the function. I'm going to come down here and I'm going to make another function and I'm going to call it puppy. And inside of puppy, I'm going to make another variable of dog and I'm going to set it equal to Noah. And inside of this function, I'm going to invoke call dog. So I'm going to return call dog. Okay, and down here, I'm going to invoke puppy. So let me wrap a console log around that. So console.log. Actually, here we'll return dog. Return dog. And console.log. Puppy. Okay, before I run this, when we call puppy, is it going to give me back Ada or Noah? And why, like, defend your choice. Tell me why you've chosen one or the other. So don't run it, give me your hypothesis here. When we invoke puppy, read inside of puppy what's happening and tell me what I'm going to get back in the console. Which dog am I getting back? Okay, most people are saying Noah because they think that when this runs, we're going to check inside of here. And since dog exists inside of the function of puppy, that's what's going to get returned to us. Okay, a lot of people are saying Ada. They're not giving me a reason for Ada. So let's double check and then we can talk about it. So save, run. And I get back Ada. Interesting. So what is happening here? Let me get my annotation tool out. So what happens here when we invoke puppy is it comes inside of this function and it runs this return statement, okay? It returns this to us. What is this doing? This is invoking call dog, which tells us to return dog. So call dog looks inside of itself and says, I don't have dog. Global, do you have it? And global passes Ada to the dog. And that's why we get Ada back in the console. Okay, does that make sense? If it doesn't, I can explain it differently, so let me know. One more time? Yeah, let's do it one more time. Okay, so what happens when we invoke puppy? Okay, when we invoke a function, what's happening is that it runs the function essentially. Okay, the return statement will return something back to us. Okay, so what the return statement is returning back to us is the invocation of call dog. So what happens then is it goes up here and it runs this function. This function returns dog. Dog does not exist inside this function, so it has to look outside of the function to the global scope, and the global scope passes it Ada, which is why we see Ada here. Okay. Let me show you another example here. So what happens if we give dog the parameter of dog? Okay. And here, when we invoke call dog, we pass it Fido. Okay, so now which dog gets logged? Are we gonna get Ada? Are we gonna get Noah? Or are we gonna get Fido? Now which dog would get logged? Fido. Okay, clear, save, run. And we get Fido back in the console. Okay, so what's happening here is that, again, this function of puppy is invoked, so it comes inside of puppy and it runs this return statement, which invokes call dog. So it comes up here and it says return dog. And in this case, dog is a parameter. Okay, so what happens here is that when this function is run, the argument that we pass gets put in place of this parameter. And that's why we get Fido here. Okay. What is the difference between return and console log? Because that's another thing that confuses a lot of people. So what is the difference between return and console.log? So console.log is just for testing. Yeah. Return actually happens. Yeah. Console log is just for viewing. I really like that. Yeah. So console log is what exactly? What is console log? What is console.log? If we had to define it, what is it? Is it a string? Is it an object? What is console log? Yeah, it's a function, or more specifically, it's a method, okay? And what this method does is that it prints something to the console. So console.log prints something to the console. Okay, whatever we put inside of those parentheses, it's going to print that thing to the console. Okay, so this is used for testing our code. We want to see what our code might give us back. Okay, return is actually executing the code. Okay, so more often than not, we want to see a return statement inside of the function because we want the function to actually give us something back. Okay, so we want the function to give us something back. Oops. Okay, so that's the difference between return and console log. Okay, so let's talk about best practices quickly before we take a little break. So we're going to try not to create global variables. And when we get into modules, it's actually pretty hard to create global variables unless we explicitly attach them to the window object. So best practices, try not to create global variables. Okay. So usually we want a variable to be defined either inside of a function, or we're defining it for a specific purpose, so inside of a block of code. So we're going to try not to create global variables. Having global variables can lead to bugs down the road, okay? Especially if more than one developer is working on a program. You might forget that a variable name was already taken, and it's going to either throw you an error, or you're not going to get an expected result. Or if the variable is defined with a var, it might give you something that you weren't actually looking for. Okay, so another thing we're going to try to do is use const until you can't, and then use let. Stay away from var. Okay. And functions are actually scoped exactly the same way that variables are scoped. So functions are scoped the same way variables are scoped. Okay, so what do I mean by that? I'm going to have a function here, and I'm going to call it say hi, and I'm going to pass it name. And inside of that function, I'm going to create another function called yell. And inside of yell, I'm going to console.log name to uppercase. Okay, so basically it's going to give me back a name in capital letters. Okay, so I'm going to invoke yell here. Okay, if I come down here and I invoke, say, hi, and I pass in Brit, comment this stuff out so it doesn't keep running, clear, save, and run. What happens here is that I get Brit back in capital letters. Okay, so it comes inside of say hi. I've passed it name. Inside of say hi is this function called yell, and it console logs the name to uppercase. And here I've invoked yell, so I can return, whoops. Return yell. Okay, if I come outside here and I say yell, okay, so let me comment that out. Here I get yell is not defined, okay? Why? Because just like variables, functions are going to be scoped to the parent function, okay? So if you create a function inside of another function, it will only ever be available inside of that function. We're going to talk about this a little bit more when we move on to closures. Okay, so if we create a function inside of another function, it will only ever be available inside of that function. Okay, so yell does not exist. Not exist on the global scope. It only exists inside of say hi. All right. We're 40 minutes in. I'm going to stop here. I'm going to give us a break and a chance to ask some questions, and we're going to talk about hoisting when we get back from the break. I'll see you in 5 minutes. All right, welcome back. Let's answer some questions. Okay, Eric says, at a high level, I understand what you're saying about const until you can't, but can you show me an example of where it's obvious I need to change it to the next best option? Yeah, great question, Eric. So a really good example of that is your for loop. So if we go back to the for loop, okay, so here, if we tried to use const and we run, okay, it's very obvious that we need to update this variable. Okay, we need to update I because we're iterating here. We're incrementing the value by 1 each time that loop runs, and we can't do that. We can't increment the value because we're using a const, and we can't change that constant variable. So here would be a good indicator that, like, hey, const isn't working. I'm going to change this to a let. Okay, another really good example would be here with this answer. Okay, so let answer, we're creating answer into existence. If 1 equals 1, answer equals true. Okay, if this was a const, we wouldn't be able to update the value of answer down here. Okay, so we would run into an error. So think to yourself, like, will this variable need to be updated? If the answer is yes, then use a let rather than a const. Okay, good question. All right, Peter asks, if I If multiple nested functions with identical variable names, I assume it always reaches to the next most local scope and not immediately to the global, if not available in the most local scope, aka the most local scope available takes precedent. Yeah, exactly. So what happens if there's two, so if we have function, hello, and in here we say const name equals Brit, and we console.log name. Okay, and we come out here and we say const name equals Peter. Okay, so what happens when we invoke hello? Let me comment this out. When we invoke hello here, clear, save, run. Okay, we get back Brit. Why do we get back Brit? Because first, let me refresh this. Come on, CodePen. First, it will check the local scope. It'll say, do I have a variable called name? Ah, I do. And it will just pass that variable name back to me. If function hello doesn't have a variable called name, then it will reach outside of its scope and it'll go to the next level scope. In this case, the next level scope is global, so it'll take this name of Peter and it'll give this one back to me, okay? Eric asks, in other languages, you can have pointers that reference a memory location of a variable's value. This allows local variables to be accessed in a global scope. Can you do something similar to this on JavaScript? No, I don't think so. I can look this up just to be sure, but I want to say no, that feature is not available in JavaScript. So can local variables be accessed on the global scope in JavaScript? Any variable declared outside of a function belongs to the global scope and therefore is accessible anywhere. Because local scope in JavaScript is created by functions, it is also called function scope. Let's see. Yeah, I want to say no. I can like do a bit more research and give you a definite answer, but I'm going to say no. I'm going to say the answer is no. So no, if it's defined in the local scope, it's restricted to the local scope. So that's why var, let, and const are scoped differently. So var is function scoped, let and const are block scoped. So you can't access those outside of their scope. All right, how do we git clone the vNext branch for our assignment today? I'll go through this at the end of the guided project so that everyone's on the same page. Is what we would call a closure happening where function yell is, or is it the whole function of say hi? Yeah, good question. So the closure happens here where yell is reaching to say hi to get name, okay? So closures are this idea that code can be identified elsewhere, yet used in a child function. Okay, so what's happening here is when we run yell, it has this parameter of name that it's console logging, and name doesn't exist anywhere inside of yell. So yell is saying, hey, I don't have name. Say hi, do you have it? And say hi, it passes it back and says, yeah, here, I have it. You can use it when you need it. That you can use it when you need it, that is a closure. So that is technically where the closure is happening, where yell is using something outside of its scope. Clear. We're going to go through closures more in this guided project. So if that doesn't make perfect sense to you yet, no worries. We're going to go through more examples of that. Is let better to use rather than var? Because I heard var can cause a lot of issues in your code. Yeah, it's like, again, we're going to scroll up to the notes that we wrote. So use const until you can't, and then use let but never var. So make sure you're writing these notes down as well. Best practices right here. So use const until you can't, and then use let but stay away from var. So exactly, var can get out of hand really quickly. All right, I'm going to comment this out. I'm going to comment that out. Okay. Is it common using a function in another function? Yes, it is common. It is something you will see throughout your career. Okay, let's talk about hoisting. Okay, who has heard the term hoisting before? What is hoisting? It was definitely in the training kit, so I hope some people went through today's training kit before they jumped into the guided project. Yeah, it has to do with how JavaScript compiles code. You're correct, Meg. Perfect. So let's talk about hoisting. So hoisting in JavaScript allows you to access functions and variables before they have been created. Okay, so allows you to access functions and variables before they have been created. There are two things in JavaScript that are hoisted. Two things that are hoisted. And those two things are function declarations and variable declarations. And variable declarations. There we go. Okay. So I'm going to create a function. I'm going to call it working. And it's going to console.log. It works. Okay, if I come down here and I invoke working, I should get back it works in the console. And I do. I can also take this function invocation and I can move it up here. And I get it works and it works. Okay, so this is the idea that we could technically invoke a function before it's been created. Okay, so it was created on line 112, we're invoking it on line 110, and it still works. This only works with function declarations. So if I comment this out and I say const working equals, and I give it an arrow function, console.log, it works. Okay, clear, save, run. Cannot access working, okay? If I say const working equals function, console.log, it works. Clear, save, run. Okay, cannot access working before initialization. So this only works with function declarations, okay? It doesn't work with function expressions. It doesn't work with arrow functions, only function declarations, okay? I could also do something like this. So I could say, I could come in here and I could invoke console.log add, and I'm going to add two numbers together, so 1 and 2. And I can come down here and I can create a function of add, and I could say num1, num2, and I can return num1 plus num2, clear, save, run. And here I get it works 3, so it comes down here and it invokes add before add was even created, and down here we can see that we get the same result. Okay, we can also do this with variable declarations with var. So I can come here and I can say var name equals Brit. Okay, and I can say console.log name, and I can come down here and console.log name. Clear, save, run. Oh, why does it give, I'm going to say my name. For some reason, CodePen has already taken the variable of name and defined it somewhere. My name. There we go. Clear, save, run. Okay, and first I get undefined, and then I get Brit. What does undefined mean as an error? What is undefined? What does undefined mean? It's telling us something. It's telling us something specific. Yeah, it means the variable has not been given a value. Okay, there's a difference between not been given a value and doesn't exist. So if I comment this out, and I'm going to comment this second console log out too, because we don't need it to run twice. Save, run. Now I get my name is not defined. Okay, so there's a difference between undefined and my name is not defined. My name is not defined means this variable doesn't exist. It hasn't been defined anywhere. Undefined means the variable exists, but I cannot yet give you its value. Okay, so undefined means, hey, my name exists, but I don't know what its value is yet. And what happens here is that JavaScript is working on what's called a two-pass compiler. On the first pass, it sets up references. So it takes my name, it brings it to the top of the scope, and it says, hey, my name, this variable, it exists. So it exists. Ugh, terrible typing. There we go. It exists. Okay, so the first pass, it exists. The second pass, it takes the value and assigns it. So it equals Brit. Okay, and we can see that that's reflected here. So on the first pass, it can see, hey, I know that this variable exists, and on the second pass, it actually returns a value to us. Okay, let me clear those. If I change this to a const, we get cannot access my name before initialization. And if I change this to a let, we get cannot access my name before initialization. So this works with variable declarations, but specifically this works with var. It doesn't work with let or const. Okay, so where is this useful? Where in the world would I use hoisting? It's not great practice, but some people like to set up their files like this. So they'll say, what does this file do? And they'll put all of their function invocations here. Function invocations here. And then they'll say, how does this file do it? And they'll write all functions here. That way someone jumping into their code can see at the top of the code quickly exactly what that file is doing. And then if they want to see how it's being done, they can scroll down and take a look. This is not really great practice, okay? So hoisting is not something that we're going to aim to be using. We don't really want to invoke our functions before they exist, but I do want you to be aware of it in case you ever see it, or you understand what's going on. Okay, so like if you see a function being invoked up here, but it's not created until later in your program, you can understand that if it's a function declaration, it's still running because it's hoisted. But this is not something we're aiming to do. All right, so that's hoisting. Know about it, but we won't be using it much in this course. And in my opinion, it's not really great practice to do so. The last topic I want to touch on today is closures. Okay, closures are probably the scariest word in JavaScript, but I'm going to try to make them less scary for you. So there's lots of articles out there on closures. It can be a difficult concept to understand the first time you're exposed to it, so I just want to call that out. I'm going to try my best to make it as easy as possible for you to understand today. So first of all, let's bring up everyone's favorite topic of nesting. And who can tell me what nesting is? So going back to sprint 1, what is nesting? What's that idea of nesting? Yeah, a function within a function, a parent-child relationship, that idea that something exists inside of something else. Okay, so closures give us the ability to put functions together. Closures give us the ability to put functions together. Okay, it's the ability to access functions from a parent level scope in a child level scope, even after that parent has been terminated. It's code that's been identified elsewhere that we can use later. So code that's been identified elsewhere that we can use later. Okay, I'm going to bring up this idea of lexical scope. And when you hear lexical scope, I want you to think of belonging. Okay, so where does something belong? Where was it created? Okay. So let's see an example of this. I'm going to make a function called country. Okay, it has its own rules and its own laws. I'm going to pass it a parameter of country name. And I am going to console.log country name. Inside of country, I am going to create another function called province. I'm going to pass it prov name, and I'm just going to console.log prov name. Okay, so inside of country, there is province. Province also has its own rules. I'm going to come out here and I'm going to invoke province. Come down here and I'm going to invoke country. And inside of province, there's also a city. Okay, so I'll say function city, and I'll pass it city name. And inside of city, we're going to console.log city name. And we'll invoke city there. Okay, so let's pass a city name. Let's pass a country or a province name, and let's pass a country name. Okay, and you might even want to write little notes here. So this closes city, this closes province, and this closes country, just so you don't get lost with your curly brackets. Okay, so I'm going to save this. All of the other code is commented out. I'm going to run this. Awesome. And we get back Canada, Ontario, Ottawa. Amazing. I'm going to take this a step further. I'm going to go inside of country, and I'm going to make a couple variables. I'm going to give it const lang1, and I'm going to set that equal to French. Say const lang2, and I'm going to set that equal to English. Okay. And I'll change this console log down here. Use some string template literals. I'm going to say $, curly brackets, lang1, and $, curly brackets, lang2 are the official languages of $, curly brackets, country name. Okay, and then I'm going to take this and I'm going to put it inside of province here. And I'm going to add to this. I'm going to say, and the most populated province is $, curly brackets, prov name. Okay. Clear, save, run. Interesting. So I got French and English are the official languages of Canada. French and English are the official languages of Canada, and the most populated province is Ontario. All right, so where is my closure happening here? And I'm going to show you on the directory level what that looks like as well. So where is my closure happening? Is it happening here? Is it happening here? Is it happening here? Where is it happening? And if you have absolutely no idea, you can write, I have no idea in that thread. Within the province function, yeah, lang1, lang2, and country name. Let me write something called a debugger statement here. Debugger, debugger, and this is going to stop the code for each debugger statement so we can see what's going on. Debugger. Okay, I'm going to save this. I'm going to open up the console. I'm going to go to sources, the sources tab, and I'm going to show you what's happening here. So let me move this down until I see that run button so I can run this code. There we go. There's that run button. So I'm going to run. Okay, it stopped on the first debugger statement. Okay, we can take a look at the scope, and we can see on the local scope, we've got the country name of Canada, the variable of lang1, and the variable of lang2. Cool. Let's run the next function. Okay, awesome. We've got the local scope here with prov name Ontario, and we've got something called a closure. And the closure gives us back country name Canada, lang1 French, lang2 English. Interesting. So now we can actually see this thing called a closure. And this closure is code that's been identified elsewhere that is available for us to use. Okay, what happens? Let me comment out these debugger statements for a second. What happens if I give city const food? And I'm going to say maple syrup. Okay. And if I come up here and I say, and the national food is $ curly brackets, food, okay, will this work? Will this work? No. Save, run. What happens? We get reference error, food is not defined. Well, that's not true because food has been defined right here. So what have we just proven here? What have we just proven? With the way that scope works, with the way that we can pass around variables, what have we proven here? Yeah, functions can only look outward. They cannot look inward. Or in other words, we can pass things down, but we can't pass them back up. Okay, so we can inherit from our parents, but parents cannot inherit from their children. Okay, so if I take this and I move it here and I get rid of food here, clear, save, run. Something's going on here. Console.log. Well, I've made a mistake somewhere. I deleted. There we go. Clear, save, run. There we go. Okay, so food works here, and if province had const animal fever, okay, I could also access the animal down here. National animal is a $ curly brackets animal. Okay, so what is happening here is that city has access to everything province has access to and everything country has access to. Province has access to everything that province has access to and access to everything that country has access to. And country can only access the things that are defined within it, or it could look into the global scope, okay? And if we uncomment these debugger statements, we can see that clearly in the console. So I'm going to save, and we'll go through that one more time. So if we hit inspect and we go over to our sources tab, and then we minimize this so we can run the code. There's the run button. Run. Okay. We can see it's stopped at country. We don't have anything called a closure. We just have our local scope, which is Canada, French, English. If we run the code again, now we have something called a closure. And the closure is Canada, French, English. The local scope is animal and prov name. And if we run this again, now we have two closures. We have a closure for province and a closure for country, okay? And the local scope is Ottawa and maple syrup. Okay, so that's the idea of closures. We can pass things up, we can pass things down, we can't pass them back up. It gives us the ability to put functions together, and it's code that's been identified elsewhere that we can use later. Okay, that's great, but where closures really come into play is if we call inner functions later on. So let's see an example of this. Save. My numbers are messed up here. Let me refresh this. There we go. Okay, so because inner scope references a variable created in our outer scope, that's what is referred to as a closure, okay? When inner scope references a variable created in the outer scope, that is a closure. And I'm going to make a function here, and we're going to call it game, and we're going to pass in sport, and we're going to give score. We're going to define score in here, and we're going to say 0. Okay, why did I use a let here? Because we're going to update score. I'm going to return a function of win. And inside the win function, I'm going to take score and I'm going to increment it. Okay, so we're taking the score and incrementing by 1. Okay, and here I want to return your sport game score is, and we'll pass the score. All right, then I can come down here and make a game. So here I'm going to say const hockey game equals game, okay, hockey. So right now, what are we setting hockey game to? So thread. What is hockey game? Is it a string? Is it an object? Is it an array? What is hockey game? Yeah, it's actually a function. So if I come down here and I console.log hockey game, okay, and I save and run this, it's going to give me back a function. Okay. If I invoke this, it's going to tell me your hockey game score is 1. If I invoke it again, and again, and again, we can see that the score is incrementing each time. So your hockey game score is 1, your hockey game score is 2, your hockey game score is 3. So what's happening here is when we call hockey game, it's accessing the win function, and then it's looking to the outer scope of the game function, and it's updating the score variable. Why is this helpful? Because we can create and maintain multiple games at once. So if I also wanted to create a basketball game, I could come down here and say const basketball equals game, and I could pass it in basketball. And if I come down here and console.log basketball, save, run. Okay, my basketball game score is 1. And yes, I know technically it should be a 2. We would have to change the function for that. But I could maintain different games at once, right? So even though my hockey game score is 4, my basketball game score is still only 1. And then if I invoke it again, it's 2, and then it's 3. So I could keep track of different scores and different games at the same time, just using this game function, which is pretty cool. So there is no way for me to access score outside of that function. So if I console.log score, let me comment this stuff out so it doesn't keep running. Okay, we get score is not defined. I also can't access win. So if I console.log win, and we might just get the first error. So let me save that. There we go, run. And we get win is also not defined. Okay, so win only exists inside of the game function and score only exists inside of the game function. Okay, so again, closures are the ability for a child function or an inner function to access variables from a higher level scope, even after that variable has been called or terminated. Okay, so we can keep accessing win every time we invoke the function. Okay, even though it's done its job, it's returned the game score, we can keep invoking it. We can keep accessing it. Okay, it's a difficult concept to get. As you continue to see examples throughout your JavaScript journey, I think it will start to make more sense. But a couple things to remember here. So the closure, it's when an inner scope references a variable that's been created in the outer scope. Okay, I'm going to stop here. I'm going to give us another break and a chance to ask more questions, and we'll go through callbacks and then the project when we get back. So I'll see you in 5 minutes. Where a web developer would use closures in combination with inner functions in creating a site. So if you were creating a game, for example, Chaz, that might be where you would use a closure anytime you're like updating a score. So if we go back to this example here, if we, for example, set this to like const player 1 equals game hockey. Whoops. And then const player 2 equals game hockey. Okay, so they're both playing a hockey game. If I invoke player 1, okay, and I could console.log player 2, that needs an ER. Oops. Player 2, there we go. And I'm going to invoke player 2 a few more times. Okay, so now we're keeping track of like which player, oh, let me comment out win. Now we're keeping track of like which player is winning. Okay, so if I run this again, so we can see like the first time it's invoked, player 1 is this first invocation. It has a score of 1, and player 2, you know what? Let me put this. I am player 1. I am player 2. This needs to go outside of here. There we go. Clear, save, run. I am player 1, your hockey game score is 1. I am player 2, your hockey game score is 1. And then if we invoke player 2 a couple more times, and then player 1 scores another goal, so we invoke that down here. clear, save, run. And there you go. So player 1, the score is 2, player 2, the score is 3, and each time you're invoking the player, that score updates. So that would be a good example of when you might use it when you're developing something. So when you're developing a game, for example. Okay, does that make sense? We got a thread going here. Does that make sense? That's probably the easiest example I can think of. Yeah, okay, cool. All right, is it best practice to declare variables at the top of a function? I mean, it depends on where you want to use those variables. Like in this case, we wanted to declare score here and then update it inside of the win function. So I would say, like, I don't know if there's a best practice to that. It would depend on where you want to use the variables. If you can give me an example, Chris, I can maybe try to answer that question a little better. Why do the basketball and hockey functions have separate increment counters? Wouldn't it be the same function, just different sports names? Yeah, but we're setting them to like what are called private variables. Okay, so player 1 is a variable that's set to game, and it's passing in hockey as the sport. This is a separate function now. So this creates a function that is set equal to the game function. But when player 1 is invoked, it's not invoking the game function, it's invoking the game function that was set to the variable of player 1. And in this case, if we're invoking player 2, it's invoking the game function that was set to player 2. But it's not just invoking the game function, it's specifically invoking the game function that was set to player 2. Okay, does that make sense? The idea of functions is that we're writing code that we can reuse over and over and over again. So we want to make it reusable. Yeah, okay, that makes more sense. Perfect. Is there standard best practice for whether to use single or double quotes apart from when one or the other is needed within a string, or is it that more dependent on the SOP of the company one works for? Yeah, so in terms of using single or double quotes, like there is not one way that is more correct than the other. I would say pick one and be consistent. So either use single quotes or double quotes. Just know that when you're using string template literals, these aren't quotes, these are backticks. Okay, so that's the only difference there. But in terms of single or double quotes, personally, I like single quotes better. I think they look nicer. That's why I use them. But really, it's up to you. So just pick one and be consistent. Okay, awesome. Let's talk about callback functions and higher order functions. This is another topic that scares people. I promise it's not that scary. So callbacks and higher order functions. We're going to make sure that you're experts on this before you leave Unit 1. All right, so a callback function is passed into a higher order function, and a higher order function receives. Those are two things that you want to remember. So higher order functions receive. Callback functions are passed in. A good example of this would be a calculator. So calculator. So I'm going to create a function called calculator. And basically, I want this calculator function to add, subtract, multiply, or divide. Okay, I want it to be able to do 4 different things. So it's going to take in 2 numbers, num1, num2. And it's also going to take in operate. Okay, so it's going to take in an operator. So add, subtract, multiply, or divide. Then it's going to return to us something. And we'll discuss what the return statement is going to look like together. Then I'm going to make a bunch of other functions. So I'm going to say const add equals function num1, num2, and I'm going to return num1 plus num2. And I'm going to say const subtract. And I didn't have to assign these to variables, by the way. I could have just written them as function declarations, so I can do it either way. And here I'm going to say function num1, num2, and I'm going to return num2 minus num1. I'm going to come down here and I'm going to say const multiply equals function num1, num2, and I'm going to return num1 times num2. Okay, and then I'm going to make one more, divide. And I'm going to set that equal to a function, and num1, num2, and I'm going to return num2 divided by num1. Okay, so these functions down here, these are really great. They do one thing and they do one thing really well. So add adds two numbers together, subtract subtracts one number from another, multiply multiplies two numbers, and divide divides two numbers, okay? I want this calculator function to be able to do all of these things. How would I write a return statement that would allow my calculator function to use the other functions to be able to do all of those things? So what will my return look like? Give me your best guess. It doesn't have to be correct. Think about this logically for a second. How do you think this return might look? And if you're wrong, that's fine. Yeah, James is definitely onto something. So basically, we want to take operate num1 and num2. Okay, so what's happening here? Okay, let me get my annotation tool out again. So we're going to pass this calculator function 3 parameters. The first parameter that we give it is going to go here. It's going to be subbed in place of there. The second parameter that we give it, it's going to be subbed here. The third parameter that we give it, operate, is going to be our callback. Callback. Okay, we're going to pass it a function. Add, subtract, multiply, or divide. So we want that to go here, because basically what we want our return statement to do is invoke either add, subtract, multiply, or divide. So let's see what this looks like. So I'm going to come down here, and I'm going to console.log so we can see the result in the console, calculator. And I'm going to give it 2 numbers, so 3, 5, and my callback function, so add. Okay, and then I'm going to do this 3 more times, and I'm going to pass it a different operator each time. So then I'm going to say subtract. Here I'm going to say multiply. And here I'm going to say divide. Okay, I'm going to clear this, save, and run. Okay, first I get 8. 5 plus 3 is 8. 5 minus 3 is 2. 5 times 3 is 15. 5 divided by 3 is 1.666667. Okay, so what is happening here, let me comment this stuff out again. what's happening here is when this function is invoked with add being the callback, it looks like this, add 3, 5. Okay, when we invoke it with subtract, it looks like this, 3, 5. Okay. When we invoke it with multiply, it's multiply 3, 5. Okay, and then divide 3, 5. Okay, which means it looks like this. 3 plus 5. 5 minus 3, because remember num2 minus num1. Well, num2 is 5 in this case. Okay, here we have 5 times 3. Okay, and here we have 5 divided by 3. Okay, so in this example, which function is the higher order function? Yeah, our calculator. Why is calculator the higher order function? Because it receives a callback function as a parameter. And by the way, a lot of times you'll see something like this, callback or CV passed in as the parameter name, but you can actually call this anything. So because it's taking an operator here, I think operate makes more sense, even though we're passing in callback functions. Okay, our callback functions are add, subtract, multiply, and divide. Why? Because those functions are being passed into our higher order functions as arguments. Okay, they're being supplied down here as an argument. All right, so that is the idea of higher order functions and callback functions. If you've got questions about that, get those into Slido, because I'm going to check before we end for today. But I did want to show everyone how to use this module project. Okay, so I'm going to refresh this. We go to module project. We're doing the baseball scoreboard challenge today. Okay, it looks like it's the correct one now. Okay, so it's been updated. We're on the master branch here. We're gonna fork. Okay, if for some reason you forked earlier and your branch looks like this, then you want to go to vnext. Okay, and you're gonna copy that, and that's the one you're gonna clone down. Here we're gonna say terminal. I make the terminal bigger so we can all see it. Go cd desktop, cd lambda projects, git clone. Okay, I'm gonna say code period and just open that up. And okay, it looks like I've got the wrong project cloned down. Okay, so what I want to do here is I want to make sure that I'm on, so if we go cd, what's it called? JS exercise. Okay, so right now I'm on the master branch. If you forked this project before, anytime before this guided project started, then you have to say git checkout vnext. Okay, now you can say code period and open it up. And now you can make another branch inside of vnext. So here we're just working on the index.js. Let me make sure that there's a index.html. There is not. You're going to want to add an index.html as well so that you can check your work. Hold on. Let me go back here and add it. If you haven't cloned it down yet, just wait a moment until I fix this. So I'm going to have to clone down the master and push up a file. Let me do that right after the guided project. So if you haven't cloned it yet, please don't clone it. If you've already, or if you haven't forked it yet, please don't fork it. If you've already forked it, then you're going to go to vnext. You're going to git checkout -b, your first and last name, checkout -b. Okay, and then you're going to open it up and you're going to say touch index.html. Okay, and inside your index.html, you can do your doc type. So if you say exclamation point tab, it's going to give you that doc type. You want to put a script tag above your closing body tag. So script src equals, and you're going to reference index.js. Okay, I can save that. I can share this in Slack as well so that you have this doc type. Okay. And then you can open up your index.html to get started, like to see your console, because now these two files are talking to each other. Okay, with the index.js, this is where you're working from today. So you don't have as many tasks today. You only have 4 tasks. But I would say these concepts are a little bit more difficult, so it may take you all day anyway. If you're finished early, a really good use of your time would be to go back through anything you're still confused about from last week, or to get a head start on tomorrow's topics. At 3 p.m. today, I'm going to go over solution code for Thursday's project. So if you had trouble with Thursday's project, jump in with me at 3 p.m. and I'm going to go through the solution for Thursday's project so that you can see what that looks like. All right, let's check for any final questions and then I will let you go for lunch. Function expressions versus function declarations, pros and cons. What exactly are you asking here? What do you mean by pros and cons? So I would say, like, it depends on what you want to use them for. So for example, function declarations are the only ones that are hoisted. So if you're looking to hoist your functions, function expressions are not hoisted. But I'm not exactly sure what you mean by just pros and cons. So if you want to clarify that in the help channel, then I'm happy to get into that with some more detail. Up to how many parameters can we have in a function? How many is considered best practice? So you can have as many parameters as necessary in a function, and that would be best practice. So as many parameters as is necessary. So if you need 3 parameters, add 3 parameters. If you need 5 parameters, add 5 parameters. Mostly you'll probably be working with 2 or 3 parameters. Wouldn't it be easier just to reclone it rather than the hassle with all of it? I mean, it's up to you, whatever you want. You can reclone it, so you can delete the project from your repo and you can refork it and reclone it, or you can go through the hassle of what I just showed you. Can you make the calculator function into a conditional statement to reduce repetition? You could, but then it wouldn't be a higher order function. The whole point of it being a higher order function is that you're passing in another function as a parameter. Okay, so if you just wrote all of this stuff inside of the same function using if-else statements, it would no longer be a higher order function. Shouldn't there be a test file in the project? No. If you're seeing a test file or you're seeing run npm watch, then you're in the wrong project. Make sure you're on the vnext branch. In fact, it might be easier, yeah, it might be easier for you all to delete the project if you've already forked it, and then I will update it and I'll @channel when it's updated so that you can fork and clone the correct project. So the vnext branch, if you've already forked it, is what you should be working on. All right, I'm gonna stop here. I'm gonna update those files and I will ping the channel as soon as it's updated and you can go refork and clone down the correct project. All right, I'll see you guys around 3 o'clock today if you want some solution code from Thursday.